We had a request to do a mechanism from Fall 21, Test 1, Part 4. And it's 3D in Part 4. Hey, we just did a acid catalyzed dehydration in our retrosynthetic analysis. We're going to do the mechanism right here. Clearly, the O has to leave. Right now, it's not a good leaving group. It needs an extra hydrogen to leave. It's going to get that from a strong acid. Strong acid catalyst. And we have an oxonium. Almost finished. Now to get that elimination, you got to ask yourself, is it going to be E1 or E2? Remember, E1 is carbocation, and I don't want to see a primary carbocation. That's a primary carbon. I don't want to see a primary carbocation. So don't do E1. You're going to do E2. You're going to need the conjugate base, because in an E2, you need a base. And you got to grab this H from, this is a different alpha than our last video. This is the one with the leaving group. You got to take the H from the one away from that. You don't have to put the Greek letters on your test. You do need to take the H from the right carbon, or else you're not going to get points. And you're done. In other books, it's called beta elimination, because you're grabbing a beta H. And that's an old reaction. If you're curious, chapter 10. This next one combines stuff from chapter 6 with stuff from chapter 11. And we're going to do a halohydrin formation here. You don't have to write halohydrin on your test. And you got to remember the water is a solvent, and it reacted with the halogen before the alkene was even on the scene. So, well, it's not that guy going down here. It's these two guys going down here. And this other little Cl minus, he's done for the day. Whatever you want to use him for, you're going to use water for instead, because there's lots of water. Don't forget the lone pair on, at least one lone pair on your Cl is needed to come back to a certain carbon of the alkene. Yeah, sadly, it's got to come back to the carbon that's more substituted. And I don't want to cross my arrows. There you go. And that's going to get us to triangle time. And water. Water, both the solvent and made in this step. So why does it hit that carbon? Well, it's the one that spends more time with a plus charge. And now we got an oxonium attached to, oh, there, yeah. So we've almost made this species here. How are we going to get there? Some of you want to use the Cl minus. What did I tell you to use instead? Use H2O. There's a lot more of it, and it's a slightly better base. Win-win. And then it's time to set up an NGP. I'm going to carefully scribble out the K, put a lone pair on the O and a minus on the O. We're going to scribble out the H. We're going to draw a bond. You can do this on the test. You can do this on the test. I'm not going to combine steps. One step at a time. Got a carbon with a leaving group. in the same molecule as a nucleophile. Make bond, leaving group leaves, epoxide is born. There you go, we made an epoxide. And that's it for that one. And next one over is making a cyclopropane from this molecule called bromoform. Bromoform. And 5 points. Probably gonna have to do 2 intermediates. KOH is a base. Bromoform, surprisingly acidic, considering the H is attached to carbon. C with 3 BRs needs to become a C with how many BRs? 2. BR says carbon with a minus. That's funny. And it leaves. Carbon now has 2 BRs. This bromide's done for the day. Carbon also has a lone pair to make the thing that made it a minus, by the way, was the lone pair, but you got rid of the extra bond here and you're back to a neutral carbon. And you don't need to show me on the test, but that's called a carbene. It's a carbon that doesn't have 4 bonds, so it's got an octet violation. But it doesn't have a formal charge. It's got bad and good. Pi attacks the carbene because there's an empty p orbital on the carbene. Lone pair comes back to, you guessed it, which carbon? More substituted, broken record. Done. That's it. It's over. Green arrow. It's kind of a cool mechanism. There you have it. Okay. So we're gonna kill this one. Oh, no, I'm not killing it very well. Here we go. Hi.